One topic that comes up when I talk about right-sizing heat pumps, not oversizing heat pumps, or HVAC systems in general, is what about extreme events? What about extremely cold events? I recommend designing to the 1% design temperature, which means 1% of the hours in the year, in a typical year, are colder than that temperature. I don't think that that's a problem, as I described in past videos. But if we do have really extreme events where there's polar vortex excursions and temperatures are well below design temperatures for long periods of time, it's something to think about. I think concerns are largely overblown, but it's not something to ignore. Let's look at an example or two. This is a hypothetical example. This is a hypothetical load line. In this example, the design temperature is 12 degrees, and here for whatever space this is, maybe this is one floor of a home, one part of a home, the design load at 12 degrees is 15,000 BTUs an hour. And at 65 degrees, there's no load. So this is how the load line works. If we superimpose on this a heat pump capacity curve, these are numbers that I made up. I think this is a great heat pump. I think this is really well sized, and of course I made it look that way. The maximum capacity at the design temperature is just slightly above what the load is, and that, in my mind, is a perfectly sized heat pump system. Concerns for heat pumps about extremely cold events are maybe more severe than for boilers and furnaces. No matter what the outdoor temperature is, for most intents and purposes, furnace and boiler capacity does not decrease as the outdoor temperature goes down. Heat pump capacity does decrease as the outdoor temperature goes down. So in this chart here, we see down at zero and down below zero, the heat pump capacity really drops. And so that can be a concern. What if I have, when the temperature goes below the design temperature and it stays there for a long time, what happens? What do I do? The reason I think that this is overblown in the examples I've showed previously, these load calculations, this load line is incredibly conservative. In the real world, you know, the actual loads we see are down here in this oval. And I showed several examples of this. The load calculations are very, very conservative. Still, it's not necessarily something to ignore. Um, think about extreme events, but in my opinion, concern for extreme events is not a reason to oversize a heat pump. I think that you're really going to be compromising efficiency during, 99.9% of the winter if you oversize the heat pump just to account for the possibility of dramatic events that are much lower than the design temperature, where you actually need that capacity. It rarely happens in my experience. One possible solution to address concerns about extreme events: resistance heat, auxiliary heat. I think this can be a great solution. If this heat pump is designed for the design load of the house, but the resistance heater is added just as a safety measure in case of extreme events or in case the heat pump malfunctions for some reason. I think you want to be careful about how you control this resistance, as I talked about in the last video, but I'd much, much rather see this than oversized heat pumps. If you don't have a ducted system, certainly other kinds of resistance or auxiliary heat, wall-mounted resistance heaters, wood stoves or pellet stoves, I've seen people kind of rely on for those extreme event concerns. And this is maybe a conversation to have on a case-by-case basis, depending who the client is. I've had some homeowners where I'm designing a system and I'll say, look, the heat pump is going to do all of your load. But if we get a week of weather that's 20 degrees below the design temperature for a week, I can't guarantee the heat pump is going to keep up. And some people say, well, no problem, I'll just plug in a resistance heater. That's not a solution for everybody, but it's a viable strategy in some cases. So in summary, I recommend people consider extreme events, but it is a low concern. I think concerns are overblown, and it is not a reason to oversize heat pumps, in my opinion. I really would hate to see. And I see it. I see it fairly often. I see HVAC systems of all kinds oversized, just in case everybody's covering their butts left, right, and sideways, which I also understand. But oversizing heat pumps can really compromise operating cost and efficiency. And I think resistance, thoughtful use of resistance or other kinds of auxiliary heat can really make a lot of sense in alleviating and addressing concerns about extremely cold events.